Welcome to part 7 of the SSR build series. I know that I want to take my rear wheel and tire off, I want to replace the tire in the tube, and I also want to measure the rear sprocket because I'm curious if I have any options aside from the stock sprocket. And I think I may look at relocating some of the electrical components, perhaps to hide them a little better than they are now, and otherwise I'm not sure if I'll get into anything else or not. In case it's useful to someone, this has a 6203 2RS bearing in this hub assembly, and the seal here is a 26 by 40 by 6.5. While I'm at it, I might as well tell you that these are 6301 2RS wheel bearings. And I've got to go order all of that stuff. I want to see if I can do anything with all the electronic components that are mounted to this section of the frame. And there's stuff on both sides, not a whole lot over here. But the battery will take up most of the area. Pretty much all of this cutout here will be taken up by the battery. So there's not actually a whole lot of room left on the inside of there. Normally this thing had body panels that came out here and covered all that up, but I don't want to run the panels, so even if I can just hide a couple of things, that would help. Some of these components will be replaced, so I'm going to make sure I use the replacement parts when I do this. For example, the CDI will be replaced with this. This is an Easy Start Performance CDI. It's got low ignition advance at low RPM, so up to 500 RPM it only advances to 10 degrees, and 500 to 2000 RPM advances to, I believe it's 20 degrees, and then after that it ramps up to 38 degrees, and that makes it easier to start than if it made a solid flat line 38 degree curve. I'll also be replacing the turn signal flasher with an LED friendly unit, and most likely this regulator rectifier will be replaced with this TrailTech regulator rectifier, because this is a very good full wave unit. From what I've seen, it maintains voltage very well when I tried it on my 2-stroke. Alright, let me show you what I've done. So on this side, I filled in any unnecessary holes. Filled in where there was a nut there and ground it down. Otherwise, pretty much the same. I did drill one hole here for a mount. Chop the tabs off the back here for the rear fender because I'm not going to use that. I've left the ignition coil mounted here. I just drilled a little bit larger hole so that the wires can go inside of there. Filled in this big hole here. And the CDI, the regulator rectifier, and the flasher I just mounted in here. For the CDI, one of the mounts that I cut off for the outside, I welded in here. That way it still uses that rubberized mount like it would stock. This just bolts on. And the flasher relay is real simple since it's round. I had two holes out here and I just zip tied that in place. I've got my wheel bearings and the hub bearing as well as the seal for the hub. And I've had my inner tube as well as the 250/17 Michelin City Pro tire for a while. So I'm going to go ahead and take care of that stuff. The only other electrical component that I need to mount is the ignition switch. And in stock form that was up here in the big gauge cluster, but I don't think I want it up there. I want to do something a little different. When you raise the seat, there's a little bit of space under here, and there are already holes, so I think I'm just going to enlarge one of the holes and mount the ignition through there. I had to drill this hole slightly larger, but the tab on the ignition just happens to be right to get a 5mm nut to fit in there very tight, so it'll make it easier to mount. While I'm working in this area, I'm going to go ahead and drill out both of these engine mount holes on each side, and I'll weld on a washer to each side just to increase the thickness around the mount area. I'm also going to drill out the passages in the engine itself, because this is the original 8mm mounting bolt And that's very loose in there. It's even worse in this back mount. And this is a 3/8 inch, which is about 9.5 millimeters roughly. And it will actually fit into the rear mount a little bit now without even touching it. And it's pretty close to fitting up here. So I'm not taking too much of the material off around here. These actually have really beefy cases compared to the stock ones. And that way I've got a little thicker bolt and a snugger fit in the motor. And for comparison, here's the stock engine. You can see the 8mm bolt is still loose in it, but there's way less material on the stock engine mount than there is in the Piranha engine. Now these are very snug in the engine. It looks like I should have done a mock-up before I messed with the frame, because if you look at the mounts, you can see that the holes don't line up. The top bolt is in. It doesn't really matter where I swing it. They just are a different bolt pattern. So I made the mistake of assuming that all of these pit bike engines would bolt in, because when I messed with them years ago, they were all the same, from the 110s to the 50s or whatever. So I just thought this would bolt in same way, didn't even bother to check, and now I'm going to have to do some work to make those align. The engine is also hitting the frame right up here. So what I'm going to do is take an 1/8 inch thick washer, roughly, and put that in between the engine and the frame. And that way I can figure out where my mounting bolts need to be, and this will give me about an 1/8 inch clearance around the engine. Now that puts the mounting hole totally forward of where the frame is, so I'm going to have to actually add on material to the frame in that area. And I've also just realized that my regulator rectifier mount isn't going to work with the bolt holes where they are, because it will run into this vent piece here on the engine. So I've actually just got to fill that hole in and then drill 2 holes higher up. The big engine's finally in there, and all of these mounts are very snug hopefully you could see that basically what I did was I just notched out the frame and I made my own 1/8 inch thick steel washers here and then welded those in place for the rear mount. I've still got to fill the hole here that I originally made for the regulator rectifier, but to be a little more efficient, instead of removing the engine and installing it again and again, while it's in here, I want to check the chain clearance to make sure the chain will actually clear the swing arm area here and that I don't need any sort of idler or anything to deal with that. I am going to be changing up the chain and sprockets a little bit, and the main reason is because this moped came stock with 420 chain. And I think 420 chain would likely be fine for what I'm doing, but if I can switch to 428 chain, which is what this is, then it should be just a little bit beefier. It's the same pitch, so it's the same distance between the teeth here, but it's a little bit wider or thicker. And more or less, that should allow it to handle more horsepower or torque and maybe a little more abuse. And the only chain I've ever ran on my old mid bikes was 420 chain, and that actually did okay, although we did have a few problems with chains breaking. But those things didn't get very high mileage. So I went with a Niche Cycle or Niche Industries X-Ring chain here. I don't know that X-Ring is really necessary for something like this. Most of the chain on small engine stuff is going to be just a plain, not even an O-ring chain. But I decided just to give the X-Ring a try. Basically, it's supposed to have longer life versus O-ring, and O-ring's supposed to have longer life versus standard. There is more friction and a little more weight involved, so it's not necessarily the best thing for power transmission, but it can be better just for longer service intervals and longer lifespan. So I went with that. This is 120 links. I think I should probably need about 100 links, but it was only a couple bucks difference, so I got plenty of them just to be sure. I also bought new sprockets intended for 428 chain. The front sprockets are actually pretty simple to get because they're not so application specific. The main thing you need to look out for with these is that these kinds of engines can have two different sizes here for the inner diameter of the shaft and the outer diameter. So these are 14-17, which means they're 14 millimeters across the small section and 17 millimeters across the large section. And then they've got a 30 millimeter distance between center to center between the bolt holes. So I got a 12 tooth and a 13 tooth, so that would allow me to change my gear ratio up a little bit. The rear sprockets can be quite a bit tougher to come by because they are much more application specific. Certain diameters inside here, certain bolt patterns, certain tooth counts required for the gear ratio you're looking for, etc. So this was basically the only sprocket that I came up with in the US at a fairly reasonable price. I got this from Dr. ATV, also called Beatrice Cycle. They didn't list any model numbers, they just listed it for, I believe, a C70 Passport it was with a 428 chain. And it had 40 teeth, which would put me somewhere where I could get a ratio that I wanted, or at least roughly in the range that I was looking for. So I went with it, and when it showed up, I found out that it was a JTR 262.40, so it's made by JT Sprockets. And I'd actually been using JT Sprockets along the way to try and find other potential sprockets that might fit this moped, but I was kind of unsuccessful there. I used the JT Sprockets online catalog to find some potential matches for sprockets that had the same inner diameter and the same bolt spacing, but unfortunately I couldn't find US dealers that actually carried these things, and at the time I just really didn't want to deal with international sellers and waiting on those to arrive or paying high shipping rates to get them. So I will put a list up here on the screen of some of the things that could potentially have sprockets that match up to this in 420 and 428 chain. But you will have to make sure that you verify what you're looking at before you buy anything if you are looking for a sprocket that fits this SSR Lazer's wheel. But maybe these will be of use to someone. Tooth counts on the sprockets were largely decided by availability because, like I said, the rear sprocket I didn't have a whole lot of options. Basically, I was going to get a 40 tooth if I wanted something in 428 chain in the US. So I knew that, and then I just had to figure out what drive ratio I wanted and determine what sprockets were needed for the front in order to achieve that drive ratio basically. So in stock form, this SSR Lazer used a 12-tooth front sprocket and a 43-tooth rear sprocket for a 3.58 to 1 drive ratio. And I took that along with the diameter of the tires and compared that to what a Piranha 160R, a pit bike that has this engine in it, used. They used the 14-tooth front and 39-tooth rear for a 279 to 1 drive ratio, and they have a much smaller tire. So I took that tire diameter, compared that information, and figured out that I probably want to be somewhere around 3.4 to 1 roughly to have a good chance at being close on my gearing as I put it together. Obviously I can adjust it. I can change the front sprockets around, and maybe I can find a different rear sprocket, or I could go to 420 sprocket if needed. When I initially install this, I'm going to try using the 12-tooth front sprocket with the 40-tooth rear sprocket, which will give me a 3.33 to 1 drive ratio. So that's fairly close to where I thought I should be based on the Piranha engine and my larger tires. If I do need something that's a little bit taller for a little bit more speed, I can use the 13-tooth front sprocket instead, and that would change the gear ratio or the drive ratio to 3.08 to 1. So I'm hoping that with the sprockets I have here that I'll be good to go and I won't have to buy anything else when I first get it on the road. If you take a quick look at the 12-tooth beside the 16-tooth, it's not too hard to figure out why I wanted to change this out before I checked for clearance issues, because obviously this small sprocket would have more trouble getting a chain around this area right here than this larger sprocket would. Right now I think I'll probably be okay. You can see there's actually plenty of clearance on the bottom side here, but it gets a little bit more tricky on the top. The chain's really slack right now, so it should be better when there's a bit more tension on there. But it is pretty close to hitting this rubber piece here that kind of goes over the frame as sort of a chain guard in a sense. And the only other problem is where this chain is so much wider, it does get pretty close to the chain guard bolt here. But I think that will be alright as well. So for right now, I'm not going to plan on putting any kind of idler or anything in place. Now that that's finished, I think I'm going to go ahead and wrap the video up. As always, thank you for watching. I do genuinely appreciate the entire audience, everyone that comments and supports me in any way. Thank you for that. Make sure you hit the like button and subscribe for more if you enjoy it to see what's coming in the future. Thanks again.